Hello everyone, and welcome to Math 1342. It is an elementary statistics class. So glad you decided to join us. As we begin our lectures in statistics, we're going to start with Chapter 1, and Chapter 1 has a lot of definitions. So a lot of what we're going to talk about today is really just defining statistics and what we're going to do in future sections or chapters. So every day we use statistics. You're exposed to it often. Oftentimes you hear something like, according to a survey, more than 7 in 10 Americans say a nursing career is prestigious. Social media consumes kids today as well, as more score their first social media accounts at the average age of 11.4 years old. So these are all samples of statistics. And one of the things this course is going to do is decide how reliable statistics can be and when they can falter. So some definitions in section 1.1. First definition is data. Data consists of information coming from observations, counts, measurements, or responses. So any information that is gathered. The next one is statistics itself. Statistics is actually the science of collecting, organizing, analyzing, and interpreting data in order to make decisions. And that's the part that's going to come in future chapters, is we're going to tie this all to how do we make decisions based on that data. How reliable is the data, and how reliable then are our results. A population is the collection of all outcomes, responses, measurements, and counts that are of interest. So if you're able to count all of them, that's considered a population. More often, we use a sample, which is a subset or part of the population. It's very, very hard to survey or collect information on an entire population, and therefore we look at the sample. And again, that helps us decide if the sample we chose is going to be able to be used for interpretations for the entire population. So, how do we identify data sets? In a recent survey, 834 employees in the United States were asked if they thought their jobs were highly stressful. Of the 834 respondents, 517 said yes. Identify the population in the sample. Describe the sample data set. So, in a recent survey, 834 employees in the United States were asked if they liked their job or thought their job was stressful. So the population then would be all employees in the United States. So all employees in the United States. The sample then is the 834 that you surveyed. So the 834 who were surveyed. The results then, or the data set, is what the results are. In this case, 517 replied yes, meaning 317 replied no. So 834 minus 517 is 317. Again, we can't survey every person in the United States. So as a result, we take a sample. Hopefully that sample is good enough that we can then say what the predictions are for the entire United States. And a lot of it has to do with how you collect that sample, and we'll talk more about that later. Next definition is a parameter. A parameter is a numeric description of a population characteristic, and a statistic, without the S, the statistic is a numeric descriptor of a sample. So P for population, P for parameter, S for sample, and S for statistic. So if we're talking about the entire population, we call that a parameter. If we're talking about just a sample, we call that a statistic. So let's look at another example. Decide whether each number describes a population parameter or a sample statistic. A survey of several hundred college student athletes in the United States found that during their season of their sport, the average time spent was about 50 hours a week. So again, now we have to decide, did we survey all student athletes? And the answer is no. So since this is not all student athletes that were surveyed, in fact, just several hundred were, that means that this was a sample. And since it was a sample, the 50 hours spent is called a statistic. Okay. So question 2 then says the freshman class at a university has an average SAT score for math of 514. So this is where population can get a little bit different, because in this case, we did survey the entire freshman class. Since it's the entire freshman class at that university, then this is considered the population of freshmen at that university. So that's every one of them. Okay? It doesn't say we have to survey every freshman at any university. It's just if this freshman class at this particular university, making that a population. So now the 514 SAT score is considered a parameter. All right, question 3. In a random check of several hundred retail stores, the Food and Drug Administration found that 34% of them are not storing fish at proper temperature. Again, not all retail stores were surveyed. So that means that that's only a sample of some of them. Since it's only a sample, then the 34% is a statistic. Right. So several times throughout this video, you will see sections that say try these yourself. That is exactly what I want you to do. As you turn in notes, you need to fill that piece out where you actually try them yourself to give you a sample of what you might see in your homework. Okay? So spend a couple of minutes working through those. And then we're going to go to the next topic, which is branches of statistics. There are 2 branches of statistics. The first one is called descriptive. And the second one is called inferential. Descriptive involves organizing, summarizing, and displaying the data. Inferential involves using sample data to draw conclusions about the population. And again, that's what we're going to really focus on in this course. What do we infer about a population? So what are we going to infer about the population based on just a sample? So descriptive statistics is probably something you've talked about before. This is going to be involved in Chapter 2. It also is oftentimes when you talk about a course in high school involving a little bit of statistics, not the entire course, but if you just did a little bit of statistics, mean, median, mode, those kind of things are descriptive statistics, and that's oftentimes what you learn a little bit in high school about. Inferential statistics actually takes an entire course then, so we can get into a little bit more meat of the course. All right, so here's another example. Determine which part of the study represents the descriptive branch of statistics and what conclusions you might draw for the inferential part of statistics. And it says a study of 2560 U.S. adults found that adults not using the internet, 23% are from households earning less than 30% annually, as shown in the figure to the right. So let's look and dissect what this is. All right, we're looking at only 2,560 U.S. adults. So the population in this case would be all U.S. adults. Okay. The sample is the 2,560 respondents. Those who responded to the survey. Of those, the 23% who earn less than 30% annually are the statistic. And this numeric value also then is describing the data. So this is the descriptive branch. So that's a descriptive branch. Again, it is describing your data. Also, and you will see often in this class, we do put data in charts. So this right here is also descriptive. So what might you infer? What might you infer? You might say that lower income prevents adults access to the internet. Now, there could be other things that you can infer, but that's just one example. Lower income prevents adults access to the internet. And that's certainly something then that somebody might look into and see how we can bridge that gap. All right, number 2. A study of 300 Wall Street analysts found that the percentage of who incorrectly forecasted high-tech earnings in a recent year was 44%. So study of 300 Wall Street analysts. So let's look at the same thing. Your population, in this case, would be all Wall Street analysts. Probably more than 300. The sample would be the 300 who responded. So there were 300 respondents. The 44% is a statistic, since it is a sample. And again, because this is a number that describes the data, it is a descriptive branch. Okay. So what might we infer in this case? Again, there may not be any right or wrong answers here. It's just what you personally would like to infer or could infer. In this case, we might say, since this number is 44%, that's almost half of the analysts incorrectly forecasting it. So you might say something like the stock market is difficult to forecast, even for professionals or for professional analysts. If you want to get more specific, we might say the stock market is difficult to forecast high-tech earnings. Maybe it's not as difficult to forecast some other things, but certainly difficult in this example to do high-tech earnings. So that's up to you then to infer something based upon that information. And then we're going to wrap up this section with the opportunity for you to try one on your own. So give this a whirl and fill in the blank. You're going to do the same thing. Find the population, identify the sample, and then which part of the study represents the descriptive branch, and then how might you draw some conclusions. And that's going to wrap up our first section.